Hello, this is Ms. DB. In this video, we're going to learn more about factoring by the greatest common factor. We will spend a couple different days on this assignment, so there's two worksheets. In this one, we're going to factor polynomials by factoring out the greatest common factor from each term. So we have a polynomial, which is this one is 1, 2, 3 terms. Each term is separated by plus or minus signs. You're going to find the greatest common factor of each term so that you can find the greatest common factor, and then we put that greatest common factor in front, and what's left after you factor that out is what's in the parentheses. And then you check it with multiplication. So you can go back to that example as you need, and here's a couple others. And let's look at how we will do that with some problems from the worksheet. I'm going to give myself a little bit more space here. All right, let's look at number 1. So the first thing that you have to do is figure out what the greatest common factor is. So the 8.1 worksheet was all about finding the greatest common factor. So we remember that we need to find the greatest common factor of the number part. So the factors of 1 are 1 and 4. And 2 times 2. Well, you only write the 2 once. So 1, 2, and 4. Let's write the number part factors of 12, the other coefficient from the other term. The factors of 12 are 1 times 12, 2 times 6, and 3 times 4. So there's the number parts. We need to find the greatest common factor. What's the greatest number that appears in both lists? And it is 4. Because there's nothing bigger than 4 in the first list, of course. Now we need to find the greatest common factor of the variable part. I'm just going to write it after the 4. So the number part, the greatest common factor is 4. We're done with that part. But now we need to see what we need to write for the variables. So there's x times x times x is x cubed. That's from the 4x cubed term. In the 12x squared, it's just x times x. So we need the common ones. So there's an x in both of them, and there's another x in both of them. X times x is the same as x squared. So we will write our greatest common factor, as with 4x cubed and 12x squared is 4x squared. Now we did that in the 8.1 worksheet. What we're going to do now that you know what the greatest common factor is we are going to factor that out of our original polynomial of 4x cubed plus 12x squared. So you start by writing the greatest common factor in front and putting a parenthesis sign. Now what goes inside the parentheses is what you would have if you divided each of those terms by the greatest common factor. So we started with 4x cubed and plus 12x squared. We off on another piece of paper, or if you can do it on the same problem if you're writing, you write 4x cubed, that's the first term, divided by the greatest common factor, which was 4x squared. And we also take the 12x squared divided by 4x squared. Then we simplify each part, and then we'll know what to put in the parentheses. So 4 in the numerator, 4 in the denominator, the 4's will cancel. 4 over 4 is 1. X cubed over x squared. Now you can go back to your rules of exponents. If you have the same base and you're dividing, you can subtract the exponents, or you can write what that means. X cubed means x times x times x. X squared means x times x. So these cancel, and I'm just left with 1x. So everything cancels except for 1x, so we would type then x in the parentheses. That's all that's left after you factor out 4x squared. Okay, now I have to do the second term. The second term is 12x squared over 4x squared. Let's do the number part first. What is 12 divided by 4? That's 3. 12 divided by 4 is 3. So that part will just be 3. What about x squared over x squared? They're exactly the same thing, so that they're going to cancel. So all I'm left with for the second part of my parentheses is 3. Now you can check this by using the distributive property. We would use the distributive property by taking the 4x squared on the outside and multiplying it by each term inside the parentheses. So we would, I'm just going to write this again. So I would check it by taking 4x squared times x. 4x squared times x, well, that's the same as times x to the 1. The rule for our exponents that we've already worked with this quarter is that you add the exponents, so we would get 4x cubed. That's exactly what we want to get because that's what we started with. So that's nice. And then we multiply 4x squared times 3, 4x squared times the second part of the parentheses. That means you just multiply the 4 times 3 and get 12, and then rewrite the x squared. So is this 4x squared, or 4x cubed plus 12x squared, is that the exact same thing that we started with for our original problem? And you can compare, and if it's the exact same thing like it is, then we know that our answer is correct, which was 4x. Here's what your answer is. I'm going to take away those little lines there. Our answer is 4x squared parentheses x plus 3. That's the answer. So number 2, 3, you're going to do the same thing. Now something interesting is going to happen in number 3. Give myself a little room. You guys can do number. All right, so what is the greatest common factor of 9p squared plus p? So let's list the factors. The factors of 9p squared would be, well, 9 is 1, 9, 3 times 3. So 1, 3, and 9 for the number parts, and p times p for the variable parts. What are the factors of p? Well, it's just p. There's only one variable. That's all it is. So the greatest common factor is just p. That's it. That's the greatest common factor. So when you write this, when you factor this, you write the p in front because that's where the greatest common factor goes. Then you put a parentheses. Then you write what is left from the 9p squared if you divide it by p. So if you take 9p squared and divide it by p, well, the p squared over p is the same as p times p over p. One of the p's will cancel, and you'll be left with a p. And the 9 didn't get canceled at all. There was no other number part. So 9p is what you would get. 9p squared divided by p is 9p. Now, when you take p divided by p, the answer is not 0, it's 1. If everything cancels, you're still left with 1. So you can't just not write anything. You have to put the plus 1 there. So the answer for number 3 is p times 9p plus 1. So you would, I'm just going to highlight that so it shows up. Whoops, my p didn't get highlighted. That's part of the answer. Your greatest common factor is part of the answer. And you would check it by multiplying back. So you would take p times 9p, and then you take p times 1. You're doing the distributive property. And you should, if you simplify that, you should get the exact same thing we started with. What is p times 9p? Well, p times p is p squared. So that would be 9 times p squared. And then p times 1, of course, is just p. So 9p squared plus p matches our original problem of 9p squared plus p. So then we know that we have the right answer. So you have some more problems like that to do. If you get stuck on any, please let me know. Sometimes, they're a little bit trickier. So you're just factoring out the greatest common factor of each one of these. And then there's an application problem, which, as you might expect, you would also be trying to factor out the greatest common factor from the expression negative 16 t squared plus 320, whoops, I typed that wrong, 320t. Factor that. Factor out the greatest common factor. And then at the end, there's a few more questions just asking to show your understanding of this topic. All right, that's it for today. We'll keep factoring for a little while longer, so you'll get lots of time to practice this. Thanks a lot and have a great day.